Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem number 27. Okay, fluid mechanics problem number 27. As usual, we first come to our statement. Okay, you purchase a rectangular piece of metal that has dimensions 5.0 into 15.0 into 30.0 mm and mass millimeter and mass 0.0158 kilogram. The seller tells you that the metal is gold. To check this, you compute the average density of the piece. What value do you get? Were you cheated? Very simple. We have to do nothing except to find out density. If density, as we find out, becomes equal to density of gold, which is given in the table of densities, then definitely metal piece is pure and we are not cheated. If density differs, then definitely we are cheated. Okay. So dear students, before going towards the solution, first we move towards the table of densities, from where we will determine what is the density of gold. Okay. This is the table of densities. Okay, only one table. Density of gold 19.3 into 10 raised to the power 3 kilogram per meter cube. Okay, this density is so often used in, has been used so often in our problems of fluid mechanics that it should be remembered by us. Okay, we should not consult table every time. Okay, so now we move towards the solution. Okay, we start our solution in the same manner as we have done with previous problems. Okay, that is to say, first we define density. Density is mass per unit volume. If a mass m of homogeneous material has volume V, its density rho is given by rho is equal to m over V, equation number 1. We know from table of densities the density of gold is 19,300 kilogram per meter cube. For comparison, okay, because we are going to calculate the density of given piece, and if that density becomes equal to or very close to this density, then we are not cheated and matter is quite okay. Okay, now in the next step, we know that for a rectangle, volume is equal to length into width into height. Okay, dear students, actually formula for calculating volume differs according to different geometrical shapes. Okay, like here rectangle is under consideration, so its formula is the simplest among all various geometrical shapes. Okay, similarly formula for calculating volume of a sphere is I think perhaps 4 by 3 pi r cube, and formula for calculating volume of a cone is 1 by 3 pi r square h, and so on. But here we are simply concerned with the volume of a rectangle, and its formula is the simplest. Okay, length into width into height. Moreover, M mass is equal to 0.0158 kg, this, which is provided in the statement. Okay, so nothing else, nothing remaining. We just put these values in equation number 1. Okay, hence equation number 1 becomes rho is equal to m over v is equal to 0.0158 kilogram over 0.005 meter into 0.015 meter into 0.03 meter. What we have done, dear students, actually all these three values have been provided in the statement in millimeter. Okay, but as you know, we are following MK system, hence our primary concern is not with millimeter, rather with meter. Okay, so when we convert millimeter into meter, we divide by 100. When we convert meter into millimeter, we multiply with the 100. Okay, so given three values have been divided with 100, that is why first value instead of 5 has become 0.005 and other instead of 15 has become 0.015 and third has become 0.03. Okay, hence density rho has become equal to 7022.222 kilogram per meter cube. To this extent our result is quite okay, but as a fashion or pattern, we convert it into 10 raised to the power 3. That is to say, we can justify our step by saying that we multiply it with 100 and divide by, we multiply and divide it with 1000. Okay, then 1000 in the denominator will take the form as 10 raised to the power 3, while 1000 in the 1000 in the numerator will take the form as 10 raised to the power 3, while 1000 in the denominator will change this figure, that is 7022 into 7.022. Okay. Now dear students, we have found the density of the given piece of gold, which has become equal to 7.022 into 10 raised to the power 3 kilogram per meter cube, while we know that density of gold is 19.3 into 10 raised to the power 3 kilogram. Okay, density of gold is 19.3, while it has become very less, about 1/3 of the density of gold. Okay, so it means we are cheated. Now, density of gold is equal to 19.3 into 10 raised to the power 3 kilogram per meter cube. Density of a rectangular piece equal to 7.022 into 10 raised to the power 3 kg per meter cube. Okay, so comparison is quite clear. This is 19, this is 7. Okay, this implies that density of rectangular piece divided by density of gold multiplied by 100 becomes equal to 36.38%. Okay, this implies that 36.38% of rectangular piece is gold, while remaining part is not gold. Okay, so we can say that given gold piece is full of impurity, because it is not appropriate to say that full of impurity. It is appropriate to say that it is 36.38% pure and remaining about 73% or 63%. Anyhow, when we subtract this figure from 100, the remaining percentage will be that of impurity. So impurity is considerably larger than purity, and hence specimen is not as per requirement, and hence we are cheated. Okay, now this table we have shown this table. There is no need to discuss this. Now we come towards the reference. Okay, reference book is Sears and Zemanski's University Physics with Modern Physics. Its authors are three authors. Okay, Hug D. Young, Roger A. Friedman, A. Lewis Ford. Its author is Pearson, and its 14th edition having been published in 2016, or 15th edition having been published in 2020 has been adopted or followed. And here chapter number 12 under title Fluid Mechanics is our concerned chapter, and this problem has been enumerated at serial number 3 of this exercise, of the exercise given at the end of this chapter. That is to say, problem number 3 of chapter number 12. That is to say, in other words, exercise number 12.3. And this is the end of our module. Okay, Allah Hafiz.